everybody. Hope you're all doing great. I'm welcome you to the Future Con conference. I'm really excited to be part of the Future Con conference this time, and we have a great content around automating offensive security testing. Hope you all enjoy, and there is a lot of trending features and things that we will talk about and what you should be looking for in the future. So let's get started. Welcoming you again. A little bit about myself. My name is Kumar Chandramouli. I am a co-founder and a chief product officer at Prancer. We are based in San Diego and globally as well in various countries. We provide security testing to look at from a hacker perspective, and then automating pen testing. And before we founded Prancer, I was part of Syncora, where I was serving as a deputy CISO, managing and building their cyber program. It's a Fortune 8 company. It's a pharma drug distribution, about a $200 billion plus company. So I enjoyed my efforts there. And before that, I was with the Ernst& Young global consulting practice. I was a practice leader for North America, building cyber practice and helping a lot of Fortune 100 clients across various sectors. And I have about 15 years of cybersecurity experience, predominantly building and managing programs around identity and access management, data privacy security, application security, pen testing programs, and vulnerability management programs. And I have built global SOCs 24 by 7 across the globe. I also built a digital forensics and a wing for investigations in helping legal aspects and presentability to the court from a corporate perspective. So pretty much a lot of cybersecurity stuff and in general security. Then after that, I went on to find this company Prancer, and this is a cyber solution will automate cybersecurity risk and governance from an eyes of an hacker with the ease. So that's a bit about me. What do we have for today? Conversation, right? So from an agenda perspective, we'll talk about why automated pen testing. Um, just to level set, everyone have a different type of understanding, but we will have a level setting, and then you understand from there what we are talking about, the challenges, and how that can be transformed, and what are the new automated pen testing methodologies that we are seeing, and how that can help, and what are the advantages and disadvantages with that. And then we also talk about what is a character of a modern attack emulation look like, and which would help you in your practice or adoption moving forward. So we'll talk about that. That's pretty much what we have in the agenda. So the very first thing, why automated pen testing, right? Um, don't get me wrong, manual pen testing is actually deep and thorough, depending on your pen tester. It can vary from based on that experience. But one thing and few things that is consistent is they are being inconsistent, meaning every pen tester have a different style of testing, so the outcomes are not always consistent. And this is resource heavy. That's number one problem. You don't get good pen testers all the time, and for the amount of demand in the market, you don't get them. That's a big problem. Then you have unlimited then you have only limited scope and time. For example, if someone's building an application and they want to go live tomorrow, and the risk team asks them, "Hey, have you done security testing?" They're like, "No," and we're going to test it. But then the manual pen testers couldn't do it within like 24 hours. It will take minimum 2 to 3 days because they have to go through all those different use cases and test cases in order to make sure that they can get the best out of the outcome, right? So It's not happening. So that's the biggest other problem with doing manual pen testing. Now, flip the coin. How do we solve that in automated? We have to be efficient. If we say automated, it should definitely be scalable, meaning the night before the live, they should be able to test it and get an outcome. So the developers can hopefully fix it before it goes live. And the outcome of the testing result should be uniform. And if you do all of that, it should definitely cut cost and error. And the more important thing is in the modern approach, it should give you an opportunity or flexibility to customize the testing to the day. Meaning, if your teams find out there is exploits happening in the market, they should be able to pick up the TTP and be able to blend in, and then it should be part of your testing. So that type of flexibility is very important in your modern day approach, right? So let's move to see what are the various pen testing methodologies that we see in the market today. The very first one is a semi-automated. So uh, this is not something that I would recommend, but what happens is the testings are all happening manually, but with different tools, but they collect all the reports into an automated fashion, and then the reporting is automated. So that's what they're calling it as semi-automated. So it's probably good for ideal for one-time testing, a limited testing, but not for scaling or having a bigger coverage and going fast. No, it doesn't serve all those purposes. Some of the tools in the market like Cobalt and HackerOne does that. That's in the semi-automated. The next one is attack simulation. So this is actually a fully automated testing. It's a standard test. So it's a great baseline attack coverage for any company. They want to keep it so that they can respond to the clients and they can respond to compliance. The problem with this solution is the organizations or who are using the platform or solution, they have to depend on the vendors to give them new tests. So it limits that capability and also limits the advanced application attacks. Like if you want to think about a temporary token or OAuth, those attacks are not built in. So for the few attacks it works perfect, but it doesn't cover the full scale or full gamut, if you would think. So like Pantera and Safe Breach falls under this category. The last category, which is what it is trending, and this is what you will see a lot more players in the market will do, is the attack emulation. So this is more advanced. You can just pick up an APT, like APT 39 or 29, and all the TTPs, and you can automate them. And it targets all the modern AppSec API vulnerabilities. It automatically goes and scrapes the dark web to get the real data. It reads the business logic vulnerability. So by that way, it can run test automated fashion. The limitation though, there are a few times that you have to require some programming language in order to do some custom testing. But those custom tests are once built in, then it can be reused many number of times. So that's the advantage and disadvantage with that. Companies do that today is Prancer. Now moving on, we'll talk about the modern attack emulation on the first part, right? So we'll stitch all together at the end. But the very first part is think your red teamer, pen tester, right? You know what they do, he or she will actually scrape the dark web. Knowing the target, they will go and scrape the dark web. They look at the DNS, what it looks like. So they gather all those, they recon all of this information, and then they try to get a foothold. They check it. If they do, then they go further down, right? So think of your platform starting to do that when you give the target name, right? It saves you a lot of time and it's automated. This is what we're talking about as part one in the modern attack emulation. It also reads the applications from outside automatically. And then when you flip it, the same platform internally, because you start with the red team attack and then you move into blue team or purple team, if you will, the tool should be doing it. where it can get in, then it can get an inventory of all your applications, APIs, infrastructure as a code, application as a code, all of that, right? So that's more important, right? So your assets, dark web info, apps, APIs, the elastic infrastructure, application code, infra as a code. It has to get inventory of everything. The reason is once you know everything, just like a retriever, your platform is actually doing that, right? Then you can go into the next stage, uh, which is where your emulation really happens. You're emulating the attack. Um, you are building a transparent attack emulation library based on policies, and these can be reused many times. And it can be in a GitHub, Gitbucket. You can share with someone, and there are a lot of developers who can develop them. You can actually use them. So it's more transparent from an attack emulation perspective. It gives you, opens you a new world of wonder that you can test and try out a lot more things in a more automated fashion. You code it once, and after that, it's automated, right? So it also gives you an ability to do versatile testing, like attack as code with your Bash, or you can use Python or Go language, etc. You can do policy as a code with PCI, NIST, HIPAA, and other standards. Uh, Policy as tags with CVE, MITRE, OWASP, and CWE. So the policy as tags is interesting, right? So you can pull the CVE and MITRE attacks and OWASP various vulnerabilities. You can tag them, and your platform will test for those. Think about this. MITRE has a array of like 80, 90, 100 plus attacks in different formats. You can tag them for specific tests, and it can perform that. And that is opening another world of GAMU of interesting testing and more accurate testing from a hacker perspective, really from an exploitation angle, right? So the platforms have to be able to accommodate that, to just include attack, and then you start testing them. This gives you a comprehensive attack surface coverage. You not only scanned all your infrastructure and application codes, infrastructure as code, all of that, but also you are going to be emulating an attack based on what was found. You don't just load Hydra and Zap without even finding an open ports or web application vulnerability. You only load them, or use cases are loaded, or test cases are loaded in order to what was found, what was inventoried. It's very custom. The tool should be able to do that. The platform should be able to do that. That's what we see in the market. Um, and this gives you a wider range of testing strategies at the end of the day. You can test for APT if your organization, it's an oil industry. Then you found another oil industry being attacked by an APT 38 or 29. Then you can exactly pick that APT 29 and run it in your environment with the real scenario, right? From red team to blue team, like purple teaming at the end of the day, like all in the platform, automated. So that's what we are seeing, and that's what we should be looking for to make it efficient, effective, and it also saves you a lot of time, right? Now, once we do this, we move on to the modern attack emulation part 3, which we talk about assessing the risk, what good it will do just by the result. It has to be correlated. Now, these are all fed into AI engine, OpenAI, and this is only training your own OpenAI tenant, right? Via platforms also can have that can be shared, but individual companies also can have their OpenAI if they wanted to. They train based on their own data. And then attack graphs, which is used by a lot of analysts. It also provides you an ability to do zero trust validation. And that's always been more theoretical, but nothing put in place. But a platform should be able to give you an ability to say, okay, it passes zero trust validation. It correlates all the risk, and it tells you a scoring based off of that. So you get an aspect of everything together. Meaning, we're talking about on-prem, cloud, infrastructure as a code in there, application code, API code, um, all of that in one single package. So that's the key. Okay, now moving on to the next part is remediation, right? So why are not we doing auto remediation? There are many low-hanging fruits, like it can be done auto remediated pretty quickly. So we have the solutions or the platforms should have an ability to auto remediate the code. Picks the code, swaps it, take a snapshot, keep it for the older snapshots for change control and anything that they want to think about or can be used, but it can be auto remediated. Now, the results can be integrated with SOC. And as you know, today, companies use different SOCs, for example, Microsoft Sentinel. Um, Most of the SOCs today ingest data from EDR, antivirus tools, uh, flow packets, network packets, right? Identity and access management, things like that comes into this SOC. But what majority of the SOCs don't have is the application exploitation data. The analysts don't understand that. It's given, especially the SOC analysts, because it's more to do with developers and you have to understand the language. But now this is given as an added advantage to the SOC integration. They get a better perspective to look at a threat and act upon it and to bring in right people to fix it or remediate that. So that is a big game winner for SOC integration. Um, the next one is once it is identified, it also has to open with Jira, ServiceNow, Teams, Slack integration. So by that way, it's automated again on the remediation part. If certain things cannot be auto remediated, which is for sure, things needs to be auto remediated, had to be auto remediated. Companies had to be bold enough to go do that. But the other things can be still the old school. It can be fixed. The AI is there to help you through remediation, which should be used as part, integral part of that. Okay. Now, all the four parts we talked about, we came to a point where it's reporting. Advanced pen testing reports with all the data above, AI correlated, map it to compliance in a single platform, and custom policies and dashboards be enabled. And it's all API driven, so it can be pushed or pulled based on the needs and to different platforms. So that's a key part of the modern attack emulation. Now, I want to wrap this up by putting all this together, right? So we talked about auto discovery, which is your infrastructure as a code, cloud infra, on-prem, cloud API, um, general application code, all of that. You are actually inventorying everything using a tool, including Dark. That's fantastic. Now, based on what we found, you load the tools to attack, so you get the real outcome. Once you do that, then everything goes into AI for assessing the risk. Once the risk is assessed, then we give it to the developers, and we actually do this in the very earlier stages, so they can get this shift left really well, so they don't have to wait until it has to go live or should be ready in order to do the old school terminology of DAST testing. They can do it early on. That's phenomenal. So they don't have to wait until they have to go DAST testing. Policy driven, the policy can be changed and customized, and it's reusable, so it can be remediated. At the end, the reporting should showcase all the compliance and pen testing in the dashboard, outcome, PDF, and everything. So that's kind of what we see in the market, where the manual pen testing is dragging along for an innumerable number of years, like 15, 20 years now. Most of it, 60 to 70%, can be automated. It's still checking the OWASP top 10 by doing it manually. It's, that really does make sense. It's a time all of that to be automated, and not just that, anything new that comes in the market, or any attacks that's happening in the market space, that needs to be customized and put for Log4j happens. It should be able to do it pretty quickly within your systems, and that should be part of your arsenal. It doesn't need to be manual testing anymore. It has to be automated, and everything is policy driven. So, and tags. So you get a lot more capability which you never thought about and which is possible. So that's kind of where we see the industry is going. And if you look at Gartner hype cycle, that's kind of what they put Prancer in the leading chart, because in offensive cycle, this is kind of what the vision, and some of the products are delivering this in the market today. So that's how we see offensive security. And when you take it back to your company, organization, or your service company, make sure you adopt these methodologies and look for these solutions so that it makes your job easier but more effective way. So that brings to end of our presentation. Um, Hope it was useful, and please feel free to reach out to me. I have put my email address over there. I'm happy to pick up a call and talk to you, and also like to know how you guys are doing it, and are you doing any modern approach, or you're trying to transition over to modern approach. uh, I'm all ears. Hope to see you next time, most of you guys in person. um, have fun. Have a great day. See ya. Bye.